Hello everyone. Now I'm going to discuss about the spin orbit coupling parameters. In our earlier video, we have discussed the inter-electron repulsion parameters, right? In that video, we have already discussed a electron configuration from an atomic system in its degenerate state will splits into different energy levels called terms. Again, terms will splits into different energy levels, further energy levels called states. And states also splits into different energy levels. Those are called as microstates, where microstates are non-degenerate energy levels. And why this electron configuration of a atomic system is splitting into energy levels? There are two causes, right? One cause is inter-electron repulsion, which we have already discussed, and the another one is spin orbit coupling. So the spin orbit coupling is the coupling of spin angular momentum and orbital angular momentum. Due to this, the perturbation in electron configuration will happen. Therefore, the degenerate state will be splits into different energy levels. And the spin orbit coupling is two types. One is capital LS coupling. Capital LS spin orbit coupling. It is for many electron and it can be called as Russell-Sanders coupling. And second one is small ls coupling and it is for single electron. And the Bohr has given the parameters zeta and lambda, where zeta is spin orbit coupling constant for single electron and its values will be lies always positive. And lambda is spin orbit coupling constant for many electrons, where zeta can be given by the expression as e square h square 2m square c square a naught and into z power 4 n cube l plus of l plus 1, where we already know the terminology, right? Where e is charge of the electron and h is Planck's constant, where small m mass of the electron, c is velocity of the electron, and a0 Bohr's radius, and z is atomic number, where small n is principal quantum number and where small l is azimuthal quantum number. And the Bohr's parameters zeta, lambda are related as below, where lambda equals to plus or minus zeta by 2s, where lambda is plus zeta by 2s for less than half-filled configurations, and where lambda is minus zeta by 2s for greater than half-filled configuration, that is greater than d5, greater than d5 configurations. And the main use of these Bohr's parameters or spin orbit coupling parameters is calculation of energy of the levels. So by using the inter-electron repulsion parameters, we have calculated the energy of terms, right? Here we using the spin orbit coupling parameters to calculate energy of the levels, that is energy of the states. The expression is Ej equals to half lambda into j plus 1 minus L into L plus 1 minus S into S plus 1. So here the terminology lambda is spin orbit coupling constant for many electron and J is total angular momentum. Capital L is orbital angular momentum and capital S is spin angular momentum. If you see the D2 electronic configuration, for D2 electron configuration, if we consider the 3f term, this 3f term can have different states, right? The states will be having different j values, and j values we can calculate like L plus S to L minus S. J values will be lies like L plus S to L minus S. So for 3f term, the L value is, so as we know, L is 0, 1, 2, 3, 4. The term symbols will be S, P, D, F, G, right? So for F, the L value is 3. and S value. The spin multiplicity is 3, right? So 2s plus 1 is 3. Therefore, S will be 1. So S value is 1. L value is 3. So obtaining J values will be L plus S to L minus S, that is 3 plus 1 to 3 minus 1. So 4 to 2 values, that means 4, 3, 2. Therefore, the states, obtaining states will be 3f4, 3f3, 3f2. Okay, so by using spin orbit coupling parameters, we calculate the energy of the states. So energy of 3f4 state is half lambda plus j into j plus 1 minus L into L plus 1 minus S into S plus 1. If we apply the values of L, S and J, we will get the energy of for 3f4 is 3 lambda, and 3f3, J is 3, L is 3, S is 1. So the energy will be minus lambda. And for 3f2 state, the J value is 2. L is 3, S is 1. So energy of the 3f2 is half lambda. So J into J plus 1 minus L into L plus 1, S into S plus 1. If we apply for the values of the J, L and S, we will get the energy of this particular state is minus 4 lambda. Now we have to arrange the states in the order, right? According to Horn's rule, we have to arrange the states of the particular term. Okay, so for D8, that is greater than D5, greater than off-field configuration. So the J value, the maximum J value, the state which is having the maximum J value will be the lower energy level. So 3f4 is the lower energy level, 3f3, and then next 3f2. Here J values we have written, and the energy what we have calculated here noted, right? And the energy difference between the energy levels, that is 3f2 minus 3f3 will be minus 3 lambda. 3f3 minus 3f4 is minus 4 lambda. So if we arrange for D2 configuration, so the J value, the state which is having the lowest J value will be the lowest energy level for less than off-field configuration according to Horn's third rule, right? So 3f2 is the lowest energy level, 3f3 and then 3f4. Okay. So if we consider again for D2 electronic system 3p term, right? For P, L is 1. For P term, L value is 1 and 2s plus 1 is the spin multiplicity is 3. Therefore, S will be 1. So J values will be L plus S to L minus S. So 1 plus 1 to 1 minus 1. That is 2, 1, 0. So the states will be 3p2, 3p1, 3p0. If we calculate the energies of these particular states, 3p2 energy, the J value is 2, L value is 1, S value is 1. So energy will be plus lambda. For 3p1, J value is 1, L is 1, S is 1 and EJ will be minus lambda. 3p0, J is 0, L is 1, S is 1. The EJ will be, that means the energy of the particular state will be minus 2 lambda. If we arrange again the states for the particular 3p term according to Horn's rule. So if it is for D8 electron configuration, so the term, the state which is having highest J value will be the lowest energy level because D8 is greater than off-field configuration, right? So 3p2 is the lowest energy level, next 3p1, 3p0, right? So for D2 electronic system, it is less than off-field configuration. Therefore, 3p0 is the lowest energy level, 3p1 is the next energy level, 3p2 is the highest energy level. This is about spin orbit coupling parameters, which is used to calculate the energy of the states.